So now we're going to look at our trigonometric functions and determine what the sign of the function is. When is my function going to be positive? When is my function going to be negative? Etc. etc. All right. So this is our coordinate system, right? We have our x and y axes. This is my x axis. This is my y axis. Now it divides it into 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. Now think about your sine and cosine for a second. If you looked at your unit circle, your sine was y and your cosine was x and tangent was y over x. Okay, so let's keep that in mind for now. So in the first quadrant, what do we notice? We notice that in the first quadrant, x and y both are positive. Both my coordinates are positive, which means sine is going to be positive, cosine is going to be positive, and tangent is going to be positive. So basically, all my functions are going to be positive in this. Okay? Then, look at the second quadrant. Our x value is negative, and y value is still positive, which means sine is going to be positive, but cosine will become negative. Now, if y is positive and x is negative, then tangent will also become negative. So the only functions that are positive in the second quadrant are sine theta and cosecant theta. Okay, because cosecant is really nothing but 1 over sine. So those are the only 2 functions that are going to be positive in the second quadrant. What happens in the third quadrant? In the third quadrant, both x and y are negative, right? If I pick a point here, it's going to be negative, negative, which means both these functions are negative. But look at tangent. I'm going to have a negative number divided by a negative number, and that's going to give me a positive number. So in the third quadrant, the only function that is positive is tangent. Well, if tangent is positive, obviously cotangent is also going to be positive, because cotangent is nothing but 1 over tangent, right? Finally, in the fourth quadrant, we have positive, negative. That is, my x values are still positive, y values are negative. So in this case, cosine will be positive, sine will be negative, which would mean tangent would be negative. And so the only functions that are positive here are cosine and secant. Okay, so we read this usually as all STC. So you have all S, T, and C, which means all functions are positive, sine is positive, tan is positive, and cosine is positive. Okay. So we looked at the signs of trig functions in different quadrants. What we're going to do now is we're going to look at the signs, and we're going to figure out what are the values of trig functions, other trig functions, given that tan theta is 3 over 2. Okay, so read this question carefully. We're given that tan theta is positive 3 over 2, cosine theta is negative, and we're going to find the values of sine theta and secant theta. Okay, so, well, if tan theta equals 3 over 2, so we know that tan theta is positive. What does that mean? If tan theta, where is tan theta positive? Tan theta is positive in the first and the third quadrant. Okay, so this means that theta is in quadrant 1 or quadrant 3. Okay, so we've already narrowed down where our theta is. Now let's see if we can further narrow it down. We're given the cosine theta is less than 0. Well, cosine theta is less than 0. We know that cosine is positive in the first quadrant and the fourth quadrant, which means if cosine is less than 0, it cannot be in the first quadrant, right? So it has to be in the third quadrant. So in this case, we can show that, we can prove that theta is actually quadrant 3, right? Again, tan is positive, so 2 possible quadrants, that's 1 and 3. And since cosine is less than 0, if it was in quadrant 1, we know all functions are positive in quadrant 1. So then cosine would have been positive. Since it's not in quadrant 1, it would have to be in quadrant 3. Okay? Well, now how do we figure this out? So we know that tan theta is 3 over 2, which for us we know is y over x. But it's not actually y over x, it's actually it's y over x, which is negative y over negative x, right? Or I could think about it, if I want to leave it as y over x, I could think about it as negative 3 over negative 2, right? Because in the third quadrant, remember, in the third quadrant, both my coordinates are negative, okay? So y would be negative 3 and x would be negative 2, right? And so then r would be square root x squared plus y squared, which is square root of negative 3 squared plus negative 2 squared, which is square root of 13. So we have r, we have x and y. We know that sine theta is going to be y over r, which is negative 3 divided by square root 13, or negative 3 square root 13 over 13. And then cosine theta, or well, we don't need cosine theta actually, secant theta is r over x, and that's going to be root 13 over x is negative 2.